Section 4.5, conditional probability. So here we deal with probabilities with kind of, let's say, more restrictive rules, where some conditions are given on that probability, and we need to know how to handle such conditions. So by definition, or we introduce this, the probability here, the probability that event B occurs given that A has already occurred, is called conditional probability. And it's represented by the format B, the probability of B given A, or slash A. That means given. Stands for given. So that's the probability of B given A. Given A. That means, this means, and we'll see more about it later on today, this wants to calculate is asking us to calculate the probability of event B to occur, assuming that something has already occurred, like the event A has already took a place. And how do we deal with this? How do we deal with such thing? First, we're gonna look at it in a way that let's see what can we get out of this, and then later we give you shortcut or a formula for it. So let's look at an example on the right side here. It says six-sided die is rolled only once. We represent F to be the event A5 is rolled, and O is the event that the die comes up odd. Well, when we roll a die, it could be 1, 2, 3, 4, 5, or 6. As you can see, these are the only options we have. So we would like to determine the probability. It's F. Means find the probability you're gonna roll 5. Well, there's only one 5 out of how many? 6. Find the probability you're gonna end up having an odd number. Well, it could be 1, could be 3, or could be 5. 3 out of 6, which reduces down to 1/2. Reduces down to 1/2. Now, what's the probability F given O? So what's the probability you're gonna roll 5 given that the outcome that is coming up is odd? So now it's not 6 anymore, no 6 total outcomes. The total outcomes here given is gonna be an odd number, the total number. So in this case, the way to find this is saying that the total number of outcomes here is gonna be the odds. How many odd numbers? We have 3 of them. Okay, how many? So F means rolling a 5. There's how many ways to roll a 5 on the 3 odd numbers? There's only one of them. So that would be 1 out of 3. Another example, what about the probability of rolling O, an odd number, given it's not F? It's not F. So how do we roll something like this, or find the probability of something like this? So what this is saying, what's the probability you're gonna get an odd number given it's not 5? So 5 is not anymore there. 5 is not anymore. Not 5 means it could be any of the numbers except 5. All numbers except 5. How many numbers are there? We have 6 total. Except 5, that will leave only 5 left. Now, how many odd are there? How many odd? Well, remember, we're doing 1, 2, 3, 4, 5, 6. We're not counting the 5. How many odd numbers are left? 2 of them. 2 of them. Now, to make this a little bit easier for you, we introduce the conditional probability rule. The conditional probability rule said the probability of B given A is the probability of A and B divided by the probability of A. Make sure this always matches the second one, not the B, but the second one. And I'm going to add to this, you can actually write this as N of A and B divided by N of A. What does that mean? That gives you how many this is telling you, instead of just dealing with probability, because what's going to happen? To find the probability on the top, always you take how many in A intersection B, or A and B, divided by the total number. The same thing, the probability of A, how many in A divided by the total. So the total cancel total because total for the same thing. And that's why we get this. We get this one. So this tells me if I want to find the probability of B given A, all I need to do is take how many in A and B divided by how many in A. It makes things easier for us. So we can look at either a standard table with values or a joint probability distribution table like this one. Either one would be fine. Let me show you this table first and try to discuss it, take some examples, see how we can work out examples from this table. What the table talks about is that they selected an adult and they found, they run some survey and they found the probability that the adult will be single given and he is male is 0.147, married male 0.281, single female 0.121, single or married female 0.284, and so on and so forth. So they can ask us to find from this, using the table, the probability that the selected adult is, let's say, number 1, divorced, given that the adult selected is a male. Let's see. So to find this, we find that we are asked about that the person is divorced given that this person is a male. Well, we told you find the probability based on the rule that the person is divorced and male divided by the probability that the person is male. And how is that going to help us? Well, divorced and male, what is it? Divorced, so you go across divorced this way down, and male, so they overlap here. So they overlap at 0.044 divided by he's a male. What's the probability he's a male? Male means you look at the male row. The male row here is 0.485, and if we divide it round to 3 decimal places, that gives us 0.091. Let's look at another example. Let's say they ask us to find the probability that the adult is, let's do it the other way around. S1, if you look in the table, S1 means male, given he's divorced. Let's see, the divorce was M4. They used M4 as a symbol for the divorce. M4. So how do you do this? Well, this is the probability is S and male and M4 divided by the probability M4. S1 and M4 is 0.044. 0.044, and the probability is M4 means you look at the divorced one is 0.104. 0.104. If we calculate on the calculator, that gives us 0.423. Notice something here. The first one I found here, this was the probability M4 given S1, and here I found S1 given M4. So note, they're not the same. Probability S1 given M4 is not the same as the probability of M4 given S1. That's a good thing to know. The other thing, what about if in case they give us not joint probability distribution, like not something like this? There are two ways if the probabilities are not given. You can take an actual table as we did in the previous section and find all the joint probabilities, Or you can use this one here that I gave you. So you take how many in A and B divided by by how many in A divided by how many in A. So we can look at a different table, such as, let's say we have called this A1, A2, and we get the total here. R1, R2, and we got total. So let's say it didn't give us probabilities, actual probabilities. They give us numbers like 3, 7, 8, 7. And they want us to find the probability of C1 given R2. We can ask more, not C1, A1. Find the probability of R2 given A2, let's say. Okay, so that's what we're gonna do now. The first thing is we try to fill up the whole table. Fill up the whole table. So here, if you add the horizontal 10, this is 15, 11, 14, total is 25, no matter how you add them. So you can use or convert this into joint probability table by finding all the probabilities and then do the division. Or we can take how many in A1 and R2 divided by how many in R2. Same thing we do here. How many in R2 and A2 divided by how many in A2. Remember, it has to be the second one goes in the denominator. The second one went in the denominator. Now, how many in A1 and R2? A1 this way, R2 this way. They overlap here. There's 8. How many in R2? R2 horizontal, the whole row adds up to 15. So it's 8 over 15. And if you divide that on the calculator, that gives us 0.533. We can do the same thing here. How many in R2 and A2? R2 and A2, there is 7. So 7 goes in there. And what about how many in A2? A2, if you add them up, this one here, total is 14. So if you divide this out, you get 0.5. So we can work with the tables regardless if it's a standard numbers or with joint probability numbers. We can still find the conditional probability in each case. Last thing we can look at, sometimes they can ask us, let's say they say the probability of A is 4 over 5. Probability of A and B is 3 over 10. What's the probability of A given or B given A? B given A. So to find that, well, the probability of B given A is given the probability of A and B divided by the probability of A. And let's see what we get. Probability of A and B is given 3 over 10, and the probability of A is given 4 over 5. Now, how do you simplify such a fraction? This is the main division sign. We can always keep the top fraction the same, switch that division to multiplication, and flip this fraction. Make it 5 over 4. You can now multiply the top by the top, 15, and the denominator by the denominator, 40. And then you can either leave it like this, or if you want to get the decimal form of this, this exactly equals 0.375. 0.375. What about if they ask us to find, let's say they give us the probability of A is 2 over 5. Probability of B given A is 1/2. They want us to find the probability of A and B. To do so, we first start by the definition or the rule. Probability of B given A is the probability of A and B divided by the probability of A. The probability of B given A, it's 1/2. The probability of A and B, we're looking for that. Probability of B is 2/5. And now, how do we find or solve this one out? You can multiply both sides. You can multiply both sides by 2/5. 2/5. By doing so, this is cancel out. So that gives me the probability of A and B equals, if you like, you can cancel these together and you get 1 divided by 5. 1 divided by 5. You can keep it like that, or you can divide it out. 0.2 is the probability of A and B.